Good afternoon, everybody. My name's Craig. As I just mentioned, I'm from Victoria and public sector solutions architect. And today we're going to talk around DDoS and what DDoS is. We're going to talk about the challenges and the impacts to customers of DDoS attacks. We're going to talk about how AWS approaches DDoS attacks, and then I'm going to introduce the Amazon or AWS Shield service and discuss that. And then I'll talk around the next steps that you can take to protect yourself and your users. So what is a DDoS attack? So a DOS attack is a denial of service attack. It's a single user against a single site. A DDoS attack is multiple users against a site, and that can be users collaborating with each other, or it could be a part of a botnet, or it could be a combination of both. But the end result is the same. Legitimate users are denied access to your website. There are many reasons that you're attacked, and there are many methods that attackers use. So one of the main reasons that we see in AWS for people being attacked is extortion. So why would you get a real job when you could just sit back and run a botnet and attack a website and extort some Bitcoin and sit back in the lounge and enjoy the money? That's a very common attack that we see. The other things that we see are sometimes customers misconfigure their websites and they don't configure for expected load, and that's a bit of an own goal. And sometimes you've got people out there that just don't like your particular organisation and they target your website. And who gets attacked and why? These figures are from Arbor Networks, which so independent of AWS. The US is by far and away the largest attacked country. South Korea is second, and that might have something to do with their gaming culture, and a lot of the gaming industry over there, and those platforms are susceptible to attacks. Australia's down there at 3%, which doesn't sound like much, but compared to Great Britain, it's about the same, so we punch above our weight there as well. Now we're going to talk about the types of DDoS attacks we see. We see them attacking at different layers in the TCP IP stack. So we see layer 3 attacks. Primarily, they're volumetric attacks, and the most common that we see exploits the UDP protocol. So UDP is a stateless protocol, so that means that it's very easy for you as an attacker to spoof your IP address, to pretend that you're somebody else. So you can connect to a UDP service and pretend you're the site that you want to attack, and then when you connect to that UDP service, the return traffic goes and attacks the site that you're attacking. And if you connect to a whole range of UDP services with this spoofed IP, they all get reflected back onto the site you're attacking. So that's what's called a UDP reflection attack, which is very common. And the types of UDP services you see out in the internet include NTP services, DNS services. They sometimes return more in the way of bandwidth and packet size than they accept in. So you get an amplification factor as well. So you have this reflection onto a site and also an amplification. At layer 4, we see state exhaustion attacks, and one of the common attacks there is a SYN flood, and this is where an attacker will initiate a lot of connections to a particular website and leave them in a half-open state. And these can run to tens of gigabits per second, and they can be quite damaging. Both layer 3 and layer 4 attacks have a sort of a common signature and are easier to detect, and therefore easier to put mitigations in place for. And then we see layer 7 attacks, and also these sometimes come in at layer 6 with impacting SSL negotiation and that type of thing with encrypted websites. These attacks are very much targeted at your website. They are targeted at your infrastructure. They take a little bit of knowledge about how you are set up. Sometimes they attack DNS infrastructure. So in October of 2016, there was a well-known attack on a large, well-known DNS provider. They generated hundreds of gigabits per second of DNS traffic, and it impacted a large number of North American and European websites. This site was generated by a botnet that took advantage of a lot of Internet of Things type smart devices, routers, webcams, and even baby monitors that were infected with the Mirai malware. So layer 7 attacks are a lot more sophisticated and come in at layer 7 of the TCP protocol. And if we break down this layer 3, layer 4 and layer 7, the type of attacks we see that layer 3 is by far and away the largest number of attacks that we see at AWS. State exhaustion, which is layer 4, the orange there, that comes in at 18%. This is across the industry, these figures. We see a little bit less in layer 4, and then 16% we see the application layer. So what is the impact of these attacks? So this talks to the duration of attack, and something that's a little bit counterintuitive if you haven't seen these figures is that the length of attacks is going down. And I'll share a little story. A few years ago, I worked for an organisation. I won't say how many years or what type of organisation, because you might look at my LinkedIn profile. But we were attacked over several weeks as part of a denial of service attack. And they attacked our DNS infrastructure and took down all our websites. And the attack was ongoing for 2 to 3 weeks. It was a continuous cycle of war rooms and incident and problem management and working with our suppliers and providers to mitigate this attack. These days, what we see an attack will come in and it'll happen within less than an hour, and then the next day they'll come back and attack for less than an hour, and again, it makes it very difficult to respond to these. And this talks to the traditional approach to mitigating DDoS attacks and some of the problems with this. That when you're under attack, you can't afford to have to set up manual escalations, manual engagement of suppliers, etc. You can't just call your ISP and ask for extra bandwidth because the attack will be over very soon. And another thing with the traditional approach is that it's common to use what's called a scrubbing site. And what a scrubbing site is that it redirects, first of all, you detect you're under attack, and then you engage the provider that does the site scrubbing. All your traffic is routed through a scrubbing site, and this could be in a different location, sometimes a different country. And that adds latency for all your users. So your users, both good and bad, are impacted by this type of approach, which is not great. And of course, with a traditional approach, if you're under a DDoS attack, you're not really in a great negotiating position. You need to engage specialised services, you need to engage with your ISPs at short notice in an emergency situation. It can be very expensive to deal with these attacks, and sometimes we see that people just pay the extortion amount rather than deal with the threat, and that's not the kind of behaviour that we would like to see. So if we see a breakdown of the types of impacts of DDoS attacks, we see that reputation is key, and reputation of the organisation I worked for. In my story, we were in the financial press for a couple of weeks, and it wasn't great for us. If you look at the resources it ties up when you could be working on other more proactive projects, it's a significant impact. And the costs can be anything from tens of thousands up into the millions. So how does AWS approach DDoS mitigation? So one of the goals of AWS is to remove the undifferentiated heavy lifting for our customers. So we can look across all our customer base and we can see the common problems and challenges that our customers have. And if we can provide a service that mitigates or helps customers with this problem, we will. If we can provide a way of automating it, templating it, whatever, we'll try and remove the heavy lifting. And all of our services, we also aim to make them highly available so that your customers and your users are always able to get to your websites. And we launched at reInvent 2016 the AWS Shield service. This wasn't something we bought and bolted onto our infrastructure. It's built into our infrastructure. It's tightly integrated using all the APIs that you know and love about AWS. We wanted it to be always on. So we didn't want, when you're under attack, you had to make a phone call, you had to switch on mitigations. We want this to be there all the time for you. And we want it to be available for customers both big and small, so that if you use more, if you're protecting more traffic, you pay more. If you're using less, you pay for less. And of course, it needs to be flexible. So attackers are always changing the way they attack your infrastructure and your sites. So our service also needs to be flexible. And the AWS Shield service has 2 tiers of operation. It has Shield Standard and Shield Advanced. If you're behind a CloudFront distribution, if your website's behind a CloudFront distribution in Sydney, you are protected already. You're protected against 96% of the most common DDoS attacks that we see. Shield Standard comes at no extra cost for our customers. If you're a little bit more of an internet savvy or customer, or you have extra requirements, you can take advantage of Shield Advanced, which I'll talk about soon. So with Shield Standard, you get protection against the Layer 3 and Layer 4 attacks I talked about earlier for 96% of the most common attacks. And it's built into our AWS services, and I'll show how that is built in later on. If you need to protect against the Layer 7 attacks, it's self-service. You can write rules using our web application firewall to protect against a lot of common attacks. We provide templates, but you can also create your own. And if you use some of our Layer 7 services like Route 53 for DNS, CloudFront for content distribution, and our load balancing technologies, you get extra protections as well, because those services have some inbuilt protections to protect against malformed traffic, for example. And all of our protections are in line and always available. If you place one of your web properties behind a CloudFront distribution in Sydney, and that can be your on-premises or existing infrastructure or web location anywhere on the internet, you can get protection just by putting it behind a CloudFront distribution. You will get access to Shield Standard by doing that. So Shield Advanced includes the benefits of Shield Standard. So you get protection on CloudFront and you get protection on Route 53. It also includes protection at the load balancing tier in 5 regions currently. We have more regions being launched in the coming months. And with Shield Advanced, you get access to always-on incident notification and reporting through the dashboard. You get advanced Layer 3 and 4 protections and Layer 7 protections. You get access to our 24/7 DDoS response team through your support, through our support organisation, and that allows you to talk to a DDoS expert when you're being attacked and get advice. You also get bill protection. A lot of customers were concerned that during a DDoS attack there are a lot of extra requests coming on to your AWS hosted sites. Will that cost me? So we've incorporated cost protection into this. Now, a lot of techos will want to know, well, what happens behind the scenes? What do we do to make this all work? And there's our alien DDoS attacker. We protect at multiple layers in the infrastructure. Firstly, up in the internet layer, we have significant network bandwidth. We host obviously a lot of companies and customers. So we have very large network pipes. And we also have edge locations. So as I mentioned previously, if you have your site behind CloudFront, your traffic is going through our edge locations. Our global infrastructure consists currently of 16 regions, with 4 more to come. That's 44 availability zones. And we currently have 77 edge locations. So what this means is not only do our regions and edge locations have large network pipes, across our globe we have an enormous amount of edge locations. So if you're a customer in Australia, you'll most likely connect to our Sydney or Melbourne edge location. If you're an attacker, you'll be connecting, if you're coming from international, we'll be connecting to another edge location. That allows us to spread out both good and bad traffic across the globe. And we can use a technique called shunting. So this allows us to manipulate BGP routing and also DNS to block traffic upstream in the network service provider. So we can, by implementing changes to BGP and DNS, we can block a lot of traffic before it even hits our infrastructure. And we can use a technique called tar pit. Now in this example, you can see that the orange lines show customers going to 2 edge locations. A DDoS attack occurs, and it's occurring mainly against this the top edge location there. We can route all the traffic of your legitimate customers to another edge location, and then the DDoS attack is not impacting. Sorry, go back a bit. Is not impacting your customers anymore using this approach. We can also use network layer mitigation. So this includes some interesting technology which we built ourselves. So we went to market and we said we want to have inline DDoS protection that does not impact the latency or throughput of our customers at scale, and we couldn't find anything to buy. So we came up with this own technology, which we call Blackwatch. So Blackwatch is the grey boxes on the left there. And this is shown in our edge services. So this is in front of our edge services, CloudFront, Route 53, and API Gateway are shown there. And this detects and mitigates very quickly, down to only takes a few seconds for a mitigation to be in place. Attacks. It ranks traffic, prioritises them, drops traffic, and it's continually ranking and deprioritising traffic based on the current loads and patterns that we see. Blackwatch is also available inside our regions, and the mitigations there take a few minutes to kick in. Blackwatch is available in 5 regions at the moment, with more regions coming online in the coming months. If we move down further into the stack, we can see AWS services. So if the attacker has got through the internet layer mitigations and the border network and the network layer mitigations, and it's down into the services. If you use CloudFront, as I said, it's already going through Blackwatch, so it's already being protected. But CloudFront also includes the ability to use a technique called geo-restriction, or a feature called geo-restriction. So if your site is behind a CloudFront distribution, you can say, don't allow customers from anywhere but Australia, for example, which is a great little feature. The other thing that you can do with CloudFront is that you can set TTL 0, because CloudFront's typically used for static content and video streaming and those types of use cases, but people can also use it just for standard dynamic website activity. Set a TTL of 0, and none of the content will be stored in our edge locations then, which is a good story for data sovereignty, which is important for our public sector customers. You can also use Route 53 for DNS requests. A lot of sites get taken down because DNS gets compromised. We use a couple of techniques, one called shuffle sharding, which is when you create a hosted zone, you get a delegated set of name servers. Each customer gets a set of 4 which are spread across all of our edge locations, and they're chosen to be very unique for customers. So it means that if one customer's Route 53 is being attacked, it's very unlikely to impact any others. We also use a technique called anycast striping, which means that all DNS requests go to the nearest location, which is a great way of spreading DNS requests across our global infrastructure. Also, if you're just using our load balancing technology, ELB and ALB, they will check for malformed packets, etc. So you get some extra benefits there. And if we go down into the web layer mitigation, we have our WAF technology. You can quite easily now write rules around rate limiting requests to sites. So you can say, a normal user, we expect to see a few clicks per second. Oh, hold on, it's gone to a few thousand. That looks a bit abnormal. You can write rules around blacklisting IPs if you see a significant change in a rate limit. You can set that yourself, and you can block IP addresses until they come down to a more acceptable click-through rate. And also, there are reputation lists on the internet which you can integrate with the WAF to constantly block known bad IP addresses. And if they get through all those tiers and they get down to your customer infrastructure, there's a bunch of things you can do down there to protect your website as well. You can choose EC2 instances which have dedicated network interfaces with enhanced networking and large network bandwidth, 10, 20 gig. You can also use our load balancing to scale out and add extra resources to scale during an attack. You can even choose which region you host in. So you can work with your account team to understand where our region sits in the global infrastructure. And there are sometimes benefits for hosting your traffic near a particular internet exchange. And you can obfuscate parts of your site which don't need to be public, so that you can reduce the attack surface area as well. And in regards to our AWS WAF service that can protect at layer 7, we just released the OWASP Top 10 white paper, which you should go and Google. It also comes with a CloudFormation template, which allows you to deploy the mitigations against the top 10 attacks very quickly using our WAF technology. There is a community repository of protections that you can look at and have a look at and use in your environment. There's a website up there as well that you can go to look for pre-configured rules. And also the WAF is available in the CloudFront product, but it's also available in ALB and ELB in 5 regions, with more coming very soon. Now, when you're using the WAF, there are 3 different modes of working with our WAF technology. The first one is self-service. You write your own. That's what comes with AWS Shield Standard. You write your own. If you're a Shield Advanced customer, you can work with our DDoS response team to write mitigations which are relevant for your website. You can also delegate authority to our DDoS response team to write protections on your behalf. So if you're under attack, our DDoS response team can start to work to mitigate the DDoS traffic going to your website. And how do we do this detection and mitigation? Well, with Shield Standard, we use machine learning and heuristics across all of our infrastructure to see what looks like normal traffic and what looks like DDoS traffic. And we use that to detect, as I said, 96% of the most common attacks in near real time using our Blackwatch devices and our monitoring systems. If you're a Shield Advanced customer, we actually get to look in and see what your traffic looks like and what's normal for you. So if you're a WordPress site and you're concerned about a WordPress pingback attack, then you can be sure that we're looking for that type of attack signature in your site. And when we detect it, we can do mitigations at multiple levels. We can, as I said earlier, we can go out into the ISP layer and mitigate attacks by manipulating routing and DNS, but we can also very quickly put in mitigations within seconds in our Blackwatch appliances and our edge services, within 5 minutes in our ALB and ELB locations, and also we can put them into our WAF technology at multiple tiers. So we can respond at multiple tiers in our infrastructure. Our customers have told us that they want to have information, they want to have data, they want to see what's happening during a DDoS attack. You already have access to CloudWatch for monitoring in the cloud, and you can look at metrics such as the surge queue length in ELB and the latency, the number of CloudFront requests that are occurring. You can look at Route 53 health checks to get an idea of what's happening in your infrastructure. But with Advanced, there is more in the way of notifications and reporting, which I'll show soon. And what are the types of deployment patterns we see? So one common pattern is people have existing sites and they realise that they've got a risk and they want to cover that off very quickly, and they can implement AWS Shield Standard or Advanced in front of their website, existing website. And that shown here is AWS hosted infrastructure, but it could, with our edge services, be on premises or one of your sites located anywhere. Another pattern we see is that especially larger organisations have done a lot of work with an existing technology provider, and they're very familiar with the tool set and the management console, for instance, and they want to continue to use that. So it's shown up here in the diagram as mod security, but could be equally another one of the security appliance partners out there. These customers implement AWS Shield in front of their site, and this allows them, it gives them defense in depth. It also allows them, a lot of times, especially the commercial platforms, are priced by instance or by throughput. This allows you to protect against 96% of the attacks we see up front, and therefore reduce the amount of attacks that your existing system has to detect. So multiple benefits to this approach as well. So pricing, as I've mentioned a few times, Shield Standard is free. If you're behind a CloudFront distribution in Sydney, you have it. So well done. If you after Advanced Protection, it's a 1-year commitment. It's $3,000 a month. There are some extra charges depending on what you're protecting. If you're protecting a CloudFront distribution, there are some costs that are in the table there. And if you're protecting an ELB, there's some other costs there as well. If you've got multiple accounts, like our big customers, if you've got but they're all part of a consolidated billing group and they're all owned by you, you only pay once and you can protect all of those sites. And also there is cost protection for ALB, Route 53 and CloudFront requests if you have more requests generated during an attack. So how do you get started? Well, you click through on the console and accept, and then this little video will show you how you protect a website and how simple it is. So you're in the console. You're going to add a new protected resource. You can see the resource types there. We're going to choose CloudFront. So this could be a website in Sydney. You get access to the CloudFront distributions in your account. You select that. Because this is a CloudFront distribution, a lot of the options further down are grayed out. You get a bit more options there if you're protecting ALB or ELB. You scroll to the bottom, and when you get to the bottom, you click the Add Protection to Resource button. This is sped up a little bit just for demonstration purposes. It takes a little bit longer in reality, but you get the idea. It's very simple to put in really good DDoS protection without too much work. And our customers wanted visibility of what was happening during a DDoS attack as well. They want to know what's happening and how they can protect themselves better in the future. So through the console, you can look at a live incident. This is not what a typical console looks like. This is our demo account. There's hopefully not this many attacks. This is showing an attack with two signatures, SynFlood, which is the layer 4 one, and an SSDP attack, which is a type of UDP reflection attack. And as you can see, that's a 60, up to about 60 gigabits per second attack that's going on there. So you can see that as it's happening in real time, and you can see the historical incidents below, so you can scroll through and see what's happened. If you want to test yourself DDoS attacks, please let us know, let your account team know, or the support team, or fill in the penetration testing form on our website, because if we detect a DDoS attack and it's just you testing, we will ban you, or not ban you, we'll stop you, block your account until we find out what's going on. So please work with us on that front. So how to choose? If you just want standard protection and just put your web property behind a CloudFront distribution, get it set up, and then you are protected. If you would like to take advantage of the extra features of the Advanced Shield, then which includes the DDoS response team, cost protection, and additional layer 7 protection and layer 3 or 4 as well, then click through on the console and you can launch Advanced Protection the way all of our products are launched and purchased. Here's some extra resources if you'd like to take a photo. There's a DDoS white paper which includes more information on the type of DDoS attacks we see and best practices for protecting your architecture and your sites against DDoS attacks. There's a white paper on WAF automation as well, which will help you get started with the WAF service. And then there's a Shield FAQ. So if there are any questions that I haven't answered during the talk today, you can find a little bit more about that. So thank you very much for listening today to this talk about DDoS and AWS Shield. I hope you've learned something and enjoy the rest of your day. Thank you.